Right, I want to say welcome to the audience to another in the series of the GOOS webinars. And this is in fact a special GOOS webinar because it's the last one for 2018. And I also have two good colleagues here to present on the JCOMM ship observations team. And this is, it's my great pleasure to introduce Darin Figurskey, who is the chair of SOT, but this is the ship observations team, but this is really his kind of night job, if you like, because by day he is also a forecaster with the US National Weather Service. And I also have Martin Kramp here, who is the ship coordinator working at JCOMM Ops, and together they're going to give you a really nice overview of the work of the ship observations team. And the ship observations team is very important to the global ocean observing system and works with other networks. Its kind of special role is coordinating all the observations that are taken across ships, and maybe these sort of research ships or commercial ships or even hospital ships. And this feeds in real time into weather forecasts, but also is useful for climate applications. But anyway, they will explain in more detail than I. So I'm going to hand over to the floor to Darin and Martin. So over to you guys. Oh, before I go, I will just say that the presentation will be about half an hour, and then we will have half an hour for questions, hopefully, thereabouts. And if you look at the panel, the kind of GoToWebinar control panel, you'll see a tag on the left-hand side in the panel called questions. And if you have a question as we're going through the presentation, please type it into there or in the questions session at the end, and then I can pick up these questions to ask our SOT colleagues. The other thing is that this is being recorded, so if it's interesting, you think colleagues would be interested in this, then please you can pass the link on at a later stage. So without more ado, I will pass over to Darin and Martin, and I'll come back in about half an hour for the questions. Okay, bye.
All right, Emma, thank you very much. Yeah, I'm Darin Figurskey, and I'm the Operations Branch Chief of the Ocean Prediction Center here at NOAA's National Weather Service in College Park, Maryland. And observations are very important in the day-to-day forecast and warning activities that we face, especially for the safety of life at sea. Martin, if you want to take just a second to introduce yourself, go ahead.
Yes, hello. So this is Martin. I'm the technical coordinator of the SOT and of the Go Ship Repeat Hydrography program working at JCOMM Ops, and also taking care of all other ship-related issues. And I will speak more about that then at a later stage today. Thank you.
All right, thanks, Martin. So if we go to the second slide, when I was been in the Weather Service now for almost 29 years, in one of my previous offices, there was an initiative called CI Flow. It was called the Coastal and Inland Flooding Observation Warning Project, and the moniker that project had was to understand weather and hydrology from the summit to the sea. And in a horizontal sense, that was a really good moniker to have. When I think of the ship observations team, I think about a really vertical expanse of understanding the atmosphere and the oceans, from well up in the atmosphere down to below the ocean surface. And when you think about the variables that the ship observations team measures, it involves atmospheric parameters such as wind speed, wind direction. It involves things right at the ocean surface, such as currents, and below the surface, such as salinity and other chemical factors there in the ocean. So there's a lot of things that it measures, and you can read the screen here of some of the primary components of the ship observation team, including the Voluntary Observing Ships scheme, the VOS, the Ship of Opportunity program, the SOOP, and a subcomponent, the Automated Shipboard Meteorological Program, or ASAP. And so again, like the moniker CI Flow had, Summit to the Sea, I think that we really have a neat moniker, neat mandate to try to get observations for forecast and warning services and a better understanding of our basically our Earth and our climate from high up in the atmosphere to below the ocean surface. If you go to the next slide, Martin. This is our kind of our organizational diagram. It's a simplified organizational diagram of the ship observations team. And we have an executive board. Under that is a VOS panel and a SOOP panel. Primary contacts certainly with the port meteorological officers, which are very important to the SOT. We have a number of task teams, and some of these task teams are doing some very, very important work. They all do very important work, some more active than others. But for example, the recruitment, promotion, and training task team working on ship recognition for long-term observing stations, also looking to update a questionnaire about VOS and the experiences in the program, challenges with working in the program, the benefits of being part of the program, so we understand more about what our ships are doing, what ships in the program are doing, and some of the issues that they're facing. They're also, and there's a slide on this a little bit later on, just mentioning that there's going to be a PMO workshop scheduled, I think, to be in Israel in 2020. They're cross task team. There's a lot of work being going on in metadata and trying to transition to a new WIGOS metadata format. Martin's going to talk a little bit more about that a little later on in the presentation. We have our masking task team, which is really working on trying to end the need, if you will, for ships to be masked. And one of the issues that we have with that, certainly as a forecaster, is when ships mask call signs. And sometimes they want to do that because they don't want people to know where they are. There could be some sensitivities there. But what it causes a forecaster to do is the lack of ability to know, really the quality control of that ship observation. Is the observation good? Can you look up that ship in a list of past records to really understand on a real-time basis, some of the biases that those ships observations have? And so we have some task teams to work to change the procedures for that, so we can really eliminate that need for masking when it comes to the receipt of meteorological and oceanographic observations. Our key performance indicators task team is doing a lot of work on performance indicators, as the task team name really implies, so that we can understand more some of the quality of the observations, how many we have. It builds greater situational awareness for the SOT program as a whole. So a lot of good work going on in a lot of our task teams. And Martin, if you go to the next slide, this is an example of a specification sheet. They're in the process of being updated and modified. But what you see on the screen is basically the mission of VOS, the mission of ASAP. We'll talk about SOOP in a moment. But some of the targets that it has in terms of desire for a number of active vessels, the number of observations that we want to have, and making sure that we hope to at least stem some of the decline in the number of observations ocean-wide that we've experienced. While the number of ships, I think, has declined over the last decade or so, sometimes the number of observations per ship increases because of automation. However, we want to make sure that we blanket the globe in as much as possible with observations, and having as many ship observations as we can of all types is very important. Going to the automated shipboard aerological program, and this is a really neat program. It began in the mid-'80s, initially a third SOT panel. But what's cool about it is it does atmospheric soundings over the ocean. And in my early career in the National Weather Service, I actually performed upper air soundings on my own in stations in Michigan, and then was in charge of that in North Carolina and in New York. And what you do is you basically fill a balloon. We filled up with helium, and in time, because helium was so expensive, some National Weather Service offices actually filled it with hydrogen. To the balloon, you attach a parachute. To the parachute, you attach an instrument, release the balloon into the atmosphere, and then the instrument attached to all that samples the atmosphere it goes up with temperature, humidity, and wind speed and direction. And over land, it's very important to assess temperature profiles, humidity profiles for the potential for thunderstorms, for the potential for what type of winter weather you might have and so on. Over the oceans, you know, it's the same thing, a better understanding of our atmosphere in the upper levels of the atmosphere to get a sense of, you know, really what's going on at those levels, temperature-wise, wind-wise, for better performance of models and for a better, again, a better situational awareness of what's going on at those certain levels. Certainly important to aviation, important to forecasters with numerical weather prediction, so on. On ships, I don't think they use hydrogen. It's pretty explosive and kind of dangerous. As long as you treat it well, it's pretty good, but I think most ships use helium. And Martin, if you go to the next slide, yeah, we kind of transition now to the Ship of Opportunity program, which, you know, is a really neat component of SOOP as well, or of the SOT as well, to focus on some of the oceanographic observations, expandable bathythermographs used to monitor boundary currents, and really the sole system for monitoring that kind of information over fixed transects. You can see in the map on the lower left, there's usually fixed transects which the observations are taken from. Ships kind of travel these back and forth, and we get the observations from those locations, from the ships that make those travels. We do surface ocean carbon dioxide to get information about you know, what the air-sea carbon dioxide fluxes are happening, and then we have thermosalinographs, that's kind of a little bit hard to say, but measure temperature and salinity from water sampled along ship tracks. And there's an example of a thermosalinograph in this image. On the previous slide, there was an example of an XBT. All of these things are really important to understand more about what's going on in our oceans. And there's going to be a webinar with our SOOP panel chair, Rebecca Cowley, along with Janet Sprinthal on the 27th of February at 20 UTC to talk more specifically about details in the SOOP program. This presentation is going to focus on, Martin, if you go to the next slide, the Voluntary Observing Ship program. And VOS has been going on, you know, for a long time in various forms. And the forerunner of the scheme dates back to, you know, most of you were twinkles in your mother's eyes back in the late 1800s. But there was recognized back at that time that ship meteorological observations are really essential for the provision of safety-related meteorological services for ships at sea. And it's important to know the meteorology that's going on out there for climate purposes, for long-term atmospheric, again, like I mentioned, the climate, understanding what's going on globally with changes in temperature profiles at all latitudes. But as a forecaster and a person in charge of operations, it's certainly important for the safety of life at sea. And it contributes to a lot of different things. And having more ships, more observations is key to helping make sure we maintain that understanding, to grow that understanding. Martin, if you go to the next slide. This is an example, and there's a YouTube link on this, but this is an example of an individual taking an observation. And doing observations in relatively clear and calm conditions on a ship is probably relatively easy. But imagine when you're a vessel dealing with 20-foot waves or 30-foot waves, or in some parts of the Pacific and the Atlantic today, dealing with 50-foot waves, how that is really hazardous to go out and try to take an observation visually. But then again, how important it is to understand the weather. And so if you'd like to take a link, take a click on the YouTube link a little later on when you get a copy of the presentation, there's a real nice 13-minute explanation of the importance of VOS, why we want to have the observations, how people take observations, and so on. So Martin, if you go to the next slide, here's again some key examples of why VOS is important. And what we have in this slide are, on the upper right, a satellite image. On the lower right, model output with an observation superimposed on that near a low pressure system. And on the left, there's scatterometer data, satellite data from winds taken near the ocean surface. On the lower left, the hotter the colors are, the stronger the wind speeds. And in the upper right, there's a ship observation basically near a comma head of low pressure. And that ship observation shows, it might be a little bit hard to see, but there's a flag with it that shows winds of 50 knots. If you could really zoom in more closely, you could actually see another little stick, which represent wind speeds of 65 knots. On the west side of low pressure, in this case, about 700, I think, nautical miles or so southeast of Nova Scotia. On the lower right is the model output, is a computer model output of the forecast at basically the exact same time of the observation. And when you look at the model output, you say to yourself, well, wow, that model output is really, really close. The comma head where the low pressure system actually is really, really close to where the model output showed that the low pressure would be. But there are a couple of key differences. In one, you see that the low pressure system by the model is displaced a little bit to the southwest. So where the ship observation has a really strong northwest wind, the model at the time indicated a southeast wind. And if you could zoom into the model data, you would actually see that the model didn't indicate anything close to hurricane force wind conditions, 64 knots or greater, which in this case, the ship in that location had. And the meteorologist, with the observations that we have through the Voluntary Observing Ship program, was able to, in this case, update a forecast to issue a hurricane force wind warning for this event. Now, did that help the ship in its way? No, but that ship really helped us get the warning out to then probably alert other ships in the vicinity to get out of the way to practice some ship avoidance. On the lower left, you see the satellite data, but satellite data, because they're polar orbiters, they have gaps. And you see in the gaps that there are basically few or no ship observations at this time. And ship observations certainly can help fill in the gaps. We know that there are strong winds with the scatterometer data, because the hotter the colors are, the stronger the winds are. So there's a wide area of storm force winds. Are there hurricane force winds in this area, to the southeast of the U.S. coast? Hard to say, in terms of a validation criteria, because there are really no ships in the area, and the satellite strips don't cover that area. Again, the more ships you have, the more area you can cover in the ocean, the more you can understand the atmosphere, the more you can be aware of things that are going on for the purposes of warning, safety at life at sea, global climate, and so on. Martin, if you go to the next slide. I want to point out that there have been a couple of unfortunate events that have caused. Oh, my light went out in my room. I got to wave my hands. It's an automated thing. So once I sit still for a while, the lights go out. But there have been a couple of unfortunate instances that have really kind of highlighted the need for observations. And one is the sinking of the El Faro that occurred back in late 2015, Hurricane Joaquin, which was a little bit difficult to predict storm, kind of meandered, was slow, eventually drifted south, and then northwest toward the U.S. coast. But it was recognized that ships providing a continuous stream of data were very important to the process of again understanding what's going on in the atmosphere. And the El Faro, it participated in the VOS program, but unfortunately they didn't practice it very much. And so through July, August, and September 2015, just before the incident occurred, the report shows there was a decrease in the El Faro's participation in the VOS program, with only one report filed for the month of September. And on the accident date of the accident during the voyage, there was an observer that prepared a report during her watch. And at 2:16 p.m., the second mate made the following statement. And this comes from the report. But the second mate sent a weather report, and I hope it works because never had to do it before. Unfortunately, the report had wrong latitude and longitude, was placed over the mainland of Cuba, and then that observation couldn't be used. So the U.S. The NTSB recognized that. The U.S. Coast Guard also recognized the need for observations and the decrease in participation in the VOS program. And you can read on the screen here about the same kind of thing I mentioned, that the observation was discounted because it was put in the wrong location, and the Coast Guard kind of calling out the vessel owner in this case to try to ensure that the proper tools and protocols are there for ship observations to be taken. And one thing that I've noted in a couple of cases, ships, we really see them try to avoid the storms, but on occasion they get into storms and get close to storms, like that one example of the observation that we had before from that low pressure system southeast of Nova Scotia. Knowing that what the conditions are helps build validity to the models, helps build situational awareness for forecasters. Martin, if you go to the next screen, this is a good example of ship weather avoidance. And you can see all the triangles out there, and you can get information like this, the ship locations, through automated information systems from things like marinetraffic.com and from other proprietary programs such as Gatehouse and Sea Vision. I'm sure there are a host of others. In this case, this is a real success story of ships avoiding Hurricane Florence as it was going to the southeast U.S. coast, and this was back in mid-September. You know, on the other hand, by the triangles, there are a whole lot of vessels out there. And from the previous couple of images that we showed, you noted the lack of observations, yet there are a whole lot of ships out there. And so there's a big potential to really grow the number of observations we get for weather, for climate purposes, and for oceanographic needs. Martin, if you go to the next slide, well, this is the ship density based on satellite AIS. And there are a lot of ship tracks for which there's a high density, the Great Circle Route over the Pacific, some circle routes like that over the Atlantic going from Central America and the Caribbean and the United States east toward Europe and back and forth. Ship routes going from South America across to Africa, from Africa to Asia, and there are a whole lot of ships, particularly some of these routes. Where we don't have many observations, certainly high latitudes, parts of the southern oceans, but any place we can get observations, they would be very, very helpful. And I think taking advantage of technology, future improvements in technology could be very helpful. And one of those could be the AIS, the Automated Information Systems. And there are a lot of application-specific messages recommended for international use that you can see on the screen here. One of those, weather observation reports from ships. And the United States, along with some other nations around the world, are looking at partnerships, either intergovernmental partnerships or partnerships with government and industry, to try to understand how we can harness more from the AIS technology to get real-time observations through the global telecommunication systems, the people that really want them and really need them. The AIS's primary goal is obviously ship avoidance, collision avoidance, but there are a number of ways I think that we can, in the future, hopefully utilize that technology to be able to get more observations around the world. Even if we get observations of pressure from ships, more ships worldwide, from that pressure we can probably derive improved wind forecasting and understanding what the wind's going on, what's going on with the wind speed and direction. From there we can probably then get a better understanding of forecasting for waves. Martin, if you go to the next slide. In the U.S. Coast Guard's Maritime Commerce Strategic Outlook, it specifically calls out the utilization, the potential utilization for the AIS, and that the Coast Guard wants to bolster engagement with NOAA to integrate real-time information to broadcast hydrographic and weather data through AIS, looking for partnerships and information resources. And I believe that the SOT can help facilitate that on a global scale. If we go to the next slide, just recently when we think about the importance of VAWS2, and this was very, very recent, there was a hearing in the United States Senate from the Senate Commerce Committee, which the National Weather Service is under, and NOAA, its parent agency, the National Oceanographic and Atmospheric Administration, run the Department of Commerce. And there was a Senate Commerce hearing on preparing for a maritime transportation in a changing Arctic, talking about the need for not just safety information, but the need for charting, just the need for observations in general to be improved in high latitudes. And this is an example of Captain Ed Page, one of the Commerce testimony providers, the executive director of the Marine Exchange in Alaska, talking about the need for improvements of many maritime things in the high latitudes, not just observations and bathymetry, but a host of things. If you want to get a listen to the testimony, you can see the link below, and you can get the streaming of that, which is very, very interesting, and again, something important to the SOT. Going on to the next slide, Martin, I think this is my last one before I turn it over to Martin. There we go. Yeah, ship observations certainly are more than just weather. As we mentioned early on in the presentation, the Ship of Opportunity program, the Automated Shipboard Aerological program, along with VAWS, provides a lot of information for climate monitoring, for climate assessments, for things like validation of the guidance, validation of satellites, for understanding better the air-sea interaction and near-ocean surface variability, getting observations that are important to quantify fluxes of latent heat, to understand the salinity, to understand ocean currents, Again, it's from basically from the tops of the atmosphere where the balloon goes up in the ASAP program and bursts and floats back down to the ground, to the ship observations that are taking at 10 meters and 30 meters and sometimes a little bit higher than that, up to 100 meters, to the XBTs, the things that are sampling items below the ocean surface. All of this is very important for understanding our global ocean observing system, for understanding our global climate, and hopefully we can continue to build partnerships to increase the number of observations, to increase the quality of observations. And some of these things we'll be talking about in future meetings. The SOT meets every 2 years. We'll be meeting in Hong Kong in April 2019. And as I mentioned before, there's going to be a Port Meteorological Officers Workshop, which was last held in 2015 in Chile, and should be held in 2020 in Israel. And with that, Martin, I'll turn it over to you.
Yeah, thanks, Darin. So before I speak about the SOT, I will speak a bit more about what we call the integrated ship coordination. So I'm, as I said, the SOT and Go Ship coordinator, but I'm also the ship coordinator in general, because I take care of all ship-related issues here. And because all in-sea networks need ships, be it for onboard installations, as we have it on the SOT, in the SOT panels, or for the deployment of instruments or recovery of instruments and so on. Ships always play a role, also for remote sensing, because we need data for calibration validation of satellites, so nothing would work without the ships, and this is why my position was set up as an integrated ship coordination position. Coordinated operations also help to better exploit synergies. So if we know that a ship goes into a certain ocean area, this will be maybe helpful for an auger or buoy operator for the deployment of their instruments. And it's in particular important that we speak to ship operators and ship captains with one voice, and that we don't have situations like they regularly happen at the moment, that a ship comes into a port and within 3 hours there will be 3 different persons coming to the ship saying, hello, I work for the weather station, and the second one will say, I work for the XBT station, and the third one will maybe say, hello, I have a few floats to deploy. So that annoys ship operators, and we need a good coordination, and that is what we have set up here in JCOMM Ops to better track all these different activities in one system by, in particular, all referring to shared and to unique identifiers. So if someone tells us I will deploy my buoy with a ship called Albatross, well, there are many ships called Albatross out there. So at present, we use in SOT the call sign of the ships as identifier, but that is something which is not unique, and we have now decided on a new SOT identifier scheme, which is unique and which refers to ships with the ICs or the IMO number as unique identifier for the ship itself. So we've developed a lot of formats inside of SOT through the metadata task teams, which also respond to the needs of the WMO integrated global observing system, WIGOS, and that is something which will play a role in the future, a growing role in the future. And we are like pioneers in this area because we are ahead of some of the other networks with this activity. So I have the pleasure here to present the latest release of the JCOMM Ops website. Here, this is the integrated system with all we see in the ocean here at JCOMM Ops, with all the floats, drifters, moored buoys, ships, and so on. So it seems to be a well-balanced system. It covers all the oceans. Of course, you can also have the static maps, which we release on a monthly basis in different projections. If you go now into the SOT scheme, you will see that the system looks quite different because we have far less platforms, in particular in the Southern Ocean. You see here also the green lines. These are the XBT reference lines. The gray dashed lines are those which are discontinued because most cases we didn't find appropriate ships anymore. So if we want to have a well-balanced system, it is important that we fill these gaps with other platforms which do similar measurements in these areas which we cannot cover with WOS ships. And that is, of course, in particular the case for for buoys with barometers. And so if we have, and here you see that, a static map for the last month, if we have a ship like here going from New Zealand to Chile, it's quite important that we know that in advance that we can benefit from such a ship to deploy buoys in that sea area, which will remain in that area while the ship has left the area for a long time already. So for the WOS program now, we have at the moment what we call 1,500 or so operational platforms, which means they submitted data in the last 30 days. But we have in total more than 3,000 ships where we expect data from, which are registered here. They come from 30 or so different countries, so there's good international cooperation, as you can see here. And it's just that we must chase all these ships which should submit data, which presently do not do. Some of this is related with the mask issue that Darin brought up earlier. We are not able to identify these ships, but there are a lot of ships out there which at present don't do what they should, and that is something we'll be working on. It's important also to note that only 20% of the total WOS produce more than 90% of the total data. And why is that so? Here, this is a different query which you see here. Here I queried all the automated weather stations, and that gives us a total here of 257 platforms at the moment. An automated station produces data on an hourly basis and all the months when the ship at least is at sea. So that brings us to like 700 or so observations per month, per month. And with over the 250 platforms, that's like between 150,000 and 200,000 observations, and that is almost the entire network, or the entire amount of data actually. Regarding the different parameters, Darin already said that most of them fortunately do air pressure, which is the most important parameter for the modelers, and the other parameters which are on normal WOS stations are for humidity, temperature of sea and of the air, wind speed and direction. And all this you can, if you are more interested in this, you can query that quite easily on the JCOMM's website. I gave you one example here for one of these KPIs we have under deployment, we have under development. So here you see, for example, the number of operational platforms. If we have a target of 2,000, that is something which will still be discussed. This is just an example here, and you can see how close we get to this or not over a timeline. Now here, what I did here, if you have one of these platforms on the interactive map, you can click on any of them if you want to have some additional information. You first have only the small window here on the left bottom. When you click on it, then you see already the SOT identifier here, by the way, as a reference, which we already implemented here, and which will be used in the future also for the data distribution. Then you can open another page here with details for the ship, which you see on the right. And you see, for example, the different sensors which are on that ship. You see when that ship last submitted data, and in particular you see the reference to the ship, because we separated the real ship metadata from the station metadata. So before that was in the same repository, and for this integrated ship coordination we had to separate it so that we can share this ship reference between the different networks. And you see here the ship reference here is the Karaoa. And if I click on that, it will open me a picture, another window here for the Karaoa. And what is interesting here to see is that while this is only one out of 2,000 or so WOS stations, the window here says me that the ship is related to more than 1,700 other platforms. And if you query everything that is related with this small research vessel from New Zealand, then suddenly you see that it plays really a vital role in for the global ocean observing system, because it has deployed and continues to deploy lots of autonomous instruments, so in particular floats and drifters. So if you look at this only through the lenses of the SOT, it's just 1 out of 2,000, but it plays a very, very important role for the integrated system. Not all those are commercial vessels. So everything that floats basically could be used as a platform to submit data, and that is also the reason why we cannot use IMO numbers as unique reference. Of course, container ships and big passenger ships, they have all an IMO number. We could have used that, but ships or vessels like this Kontiki float here, they don't have an IMO number, but they can play a very, very important role because they sail in areas where we have no other ships. So in this case here, Cecilia, which you see on the right, is a panelist from the IPCC even. So we had a very, very experienced onboard scientist on this float, and the float not only submitted weather data but also deployed surface drifters. And if you imagine how smooth the deployment is here from such a Kontiki float compared to when you throw such an instrument overboard from a container vessel from 10 meters or more of decade, and it's at a speed of 18 knots. That's a very violent deployment, and some, in particular, the floats are quite fragile. So if we have such a platform here, that might be a much more appropriate way to get them into the water. I have one slide for sailing. We have done quite a lot of things with sailing ships, again, because they sail in areas where we have no other opportunities. And what you see here on the left, actually, we sometimes contribute to the Mariner's weather log from NOAA to tell the story of such vessels. And on the left, you have the Oceania Scientific Program, and you see here on that map, which was in that edition of the MWL, Antarctica, and you see on that map a whole year of VOS positions, and you see the red line, that is where Barca Europa sailed. So only one ship, and of course this ship plays in that case a very, very important role, because if we get the drifters in the water from such a ship sailing in these areas, at least we get data even if we have no ships there. Barca Europa is also important to us because they hosted, for example, during one of the JCOMM meetings in Cape Town, they hosted a coffee break, and we were able to exchange with the captain which is holding the float here with the red t-shirt. That is probably the most experienced old school captain in the world. And they also hosted science expeditions for us already when the ship was in port during sailing weeks. And on the right, just a performance yacht sailing again from New Zealand to Cape Horn and back to Europe. Then you see again that there were no other ships, and these people agreed to deploy some instruments for us, and they would help us to get data from that area even long after the ship has left the area, and we had really no alternative to these deployments at that case. Excuse me. We have done a couple of other things with sailing races in particular, but that is something which is more interesting from the SOOP perspective, and which we'll raise again in the next webinar. The Volvo Ocean Race has just contributed to the observing system, as we have a cooperation agreement with the IMOCA community through the IOC, and we've just tested one of these systems in one of these races, and we'll get data sets from around the world races quite frequently now through the sailing community. For such extraordinary ships, many national agencies, they give such certificates of appreciation to the ships. We here do that for ships which are not part of a national fleet, and that is something these ships then can put into the galley or so to remember that they are part of the global ocean observing system. If you want more, we have a VOS poster, which is available through the VOS website. We also have a VOS brochure, which is a 6-pager, which is mostly about VOS, but also about other associated or linked observing programs. We have a mailing list, which you can subscribe to just by sending sub-SOT to simpa@cls.fr, or you just send me a message. If you want, and if you have something innovative to talk about, which is interesting for the SOT, you could contribute to the next session of the SOT, which will be in Hong Kong in April. So we have an innovation workshop where such contributions are very welcome. And of course, you can enjoy the upcoming SOOP webinar on 27th February, as Darin and Emma already mentioned. Before I close here, something which is very important for us, please share your metadata. If you are operator of a platform or of a cruise ship or whatever other ship, and if you have something to tell us, please do so. We can make things much more efficient and much better if we know where you plan to deploy your platforms, and if you know in particular where you plan to send your ships. And then we can do the matching between the two of us, but we need these information that is crucial for us. And that said, I'll give it back to Emma at headquarters. Thank you.
Great. Thank you, both Darin and Martin, for a really excellent run through the work of SOT, but also touching on the work of ASAP and SOOP and the role they play. So we have some interesting questions coming in, so I'm going to pick those up. But first of all, one of the questions was about whether this presentation will be available, and absolutely yes, along with the recording of the of this presentation, so that you can share that should you want to share with colleagues. And that's on the GOOS website underneath webinars, and it says past webinars, and that's where both the presentation and the recording will be. And that there are many other interesting presentations up there, so I'd encourage you to take a look. So I have a first question from Huiying Huang. So this is I'll rephrase it slightly. So it's asking about the accuracy of the ship observations and saying, are they accurate enough to do CalVal satellite observations? So I'll throw that over to whoever wants to answer that one.
Yeah. This is Darin. I think that many of them are. We can really assess the accuracy of a ship observation over a long term through quality control programs. And every observation might have a little bit of a bias, but in a lot of cases, good quality ship observations, for example, from a wind speed bias, may be biased by a knot or two, and so that makes it actually very good for things like trying to validate what you see from satellite data. One of the things that we notice here as forecasters is that, especially in the higher ends, the satellites tend not to pick up some of the higher waves and especially the higher winds as much as we might like. And we want ships to avoid that kind of activity. But if the ship would get into that activity, again, that having that ship observation would be really critical to understand really what's going on in the atmosphere. Because again, sometimes in the higher winds, the satellites don't quite measure it quite that high. Martin, do you have anything to add with that?
Yes, I just want to add that this is where the metadata actually plays a very, very important role. If you can see through the metadata that this is let's take pressure, a PDB 330 from Vaisala, a high quality instrument, which has been calibrated just 3 weeks ago or so, then you will probably know, and you see also where it is positioned on the ship through the metadata, so that there is that this is not inside pressure, but real atmospheric pressure from that position, then you know that this is probably the best quality data you can get. And if you don't have that information, as you said, Darin, earlier today, then you probably won't use that information for calibration.
Okay, so that's really helpful. We have a question from Rick Wanikoff, who is interested to understand a little bit about the autonomous surface vehicles, and whether SOT sort of feels that they have a role in filling the gaps, and whether you would sort of cooperate or would you even include them in the VOS or the SOT framework? Is that something that you've thought about? Let's say sail drones as a sort of a new technology.
Well, I know here in the National Weather Service, we've been looking at that kind of technology for sail drones and the like. They cover a certain area. I don't know about the expense to be able to put them out. Any data is better than none. So it's important to get as much data as we can. I guess you have to assess the cost of the data. And the quality of the data, how long the data will be out there. Do you have to chase the sail drones around and the like? I know certainly in my year in the SOT, we really haven't talked specifically about sail drones yet, but at this point, I wouldn't be exclusive of anything at this point. And I don't know if, Martin, you've had anything to add from a historical standpoint, has SOT really been more involved in discussion about autonomous vehicles or not?
Well, sail drones or wave gliders, they rather fall under the data buoy cooperation panel. But this doesn't really matter because we closely work with the data buoy cooperation panel. So wherever they find a home, my answer to the question is yes.
Yeah, good. Right. So another question is asking about the Volvo Ocean Race Science Monitoring Program, and that was involved in taking a number of measurements. I mean, they got involved with microplastics, taking chlorophyll A and other measurements. Were they also taking measurements for SOT?
Yeah, I can answer that question. So
Yes,
the answer is yes. And excitingly, one of the sponsors of the Volvo Ocean Race was Inmarsat. So the communication to shore was not such a big issue in that case. And they were sending from their own navigation systems. And I mean, in particular, wind. All is about wind and sailing. They submitted, for example, wind data several times per minute back to shore. And we set up through a number of SOT members then a way to recover that data and to put it onto the GTS. So the answer is yes.
Well, that's amazing, isn't it? I mean, the amount of observations you were getting from them. And as Darin was saying, they're also going to very remote parts of the oceans where we just don't have that many observations. So that's really interesting and a really good link up.
It's also interesting. If I would just want to add that it's also interesting in terms of outreach, because when we first worked with the Volvo Ocean Race in the last edition, that is then like 4 years ago now or so, when they dropped drifters for us, this went out to like 20,000 media points or so around the world. And when you Googled the day after, we probably never had a higher visibility for the Global Ocean Observing System than the day after this event.
Fantastic. Right. There's another interesting question come through. I think I know the answer, but I will pass it over to you guys. It says, and it's how many ships, and this is again from Rick, how many ships in the VOS system are paid to provide their services? And there is a vessel that's supported by Argo on selected cruises, but it's my impression that it's in the name. This is under SOT. It's the voluntary ships operations, and so I'm assuming that all of these ships are in fact voluntary and providing their data for sort of the greater safety of life at sea.
Yeah, right. In my knowledge, I don't know of any entity that's paying any vessel to provide the observations. Now, observations that are sponsored by a national meteorological hydrological service, such as the Weather Service or German Weather Service or whatever it is, they may provide the equipment to put on the vessel to allow then that ship to take the observation. But I don't think there's any funding changing hands to get the observations. And Mark, you want to add to that?
Well, it can happen because something that we are really eager to have are visual observations, like for the sea state or sea ice and so. And there are some of the systems where, in particular the automated systems, where ship officers have the opportunity to add visual observations. And when they do that, they may get a few pennies or so per observation from the recruiting weather service. That is where they get paid. But I mean, it's maybe even more importantly to note that we have a lot of ships which really want to participate and who are willing to use their own particular satellite communication system to submit the data, where they even pay for us, like the SATCOM costs.
Right. Well, that's fantastic. I've got many more questions coming in, so I'm going to run through them so we have enough time to catch everybody's interest. Is there any interest in obtaining direct measurements of the subsurface ocean currents, shipboard Doppler sonar, or are there any plans to pursue these measurements? And maybe I would also ask in terms of bathymetry as well. I would perhaps include that in my question. And this question comes from Julia Hammond.
Mark, you want to take that one first?
I can take it. It's something actually which I forgot to say. I wanted to raise the bathymetry thing. because we know a lot about the surface of the moon, we even know a lot about the surface of Mars, but we know almost nothing compared to the surface of to the sea bottom. So we have really a big lack of data here. And given that we, through the VOS systems, are quite frequently already connected to the ship navigation system, even if we can't measure to the sea bottom, we at least would be able to say there is a minimum depth here, which is quite important for the safety of navigation. So we invited the IHO, which is the hydrography institution sitting in Monaco, to participate in the last SOT meeting, and now are working with them on a better cooperation to find a way to integrate these data maybe into the VOS data stream. Given that we already are connected, it's just another piece of data which doesn't seem to be too complicated. And I'll let you the other part of the question, Darin.
And refresher, what the other part of the question was?
Ocean currents, whether there was any plan to integrate sort of ocean currents measurements in some ways.
Yeah, I think so. I think that again, the SOT really wants to look at the observations from the atmosphere to the near ocean surface to the ocean currents and things. And I think we're working on those issues already. I think that certainly the next webinar will talk a little bit more about that. But yeah, that's definitely something that we're interested in.
Okay, great. Now I have a more technical question, and it sounds like from somebody who's actively using the data. So it's from Rich Lamire, and it says, I perform many remote barometry comparisons with widely varying results. Is there any attempts being made to standardize ships' barometers? Now, I have no idea about the answer to that question, but I don't know. Martin, is this an area that you know something about?
Well, ideally, we hope one day that what is not the case at the moment will maybe become the case, that submitting weather observations could be something that is mandatory through IMO, as it is the case for the positions through the AIS system already. And in that case, we probably will make some progress regarding the instruments that can be used for such an application. And maybe it's also could work through something which is just happening right at the moment now. Ideally, we would like to recruit a whole company for our observing network, and not bottom up, go in a port through a port meteorological officer to a captain and say, would you maybe be willing to contribute to the system? Of course, it would be much more efficient if top down, we on executive level would agree that a whole company agrees to contribute with all their ships to the system, and that when they construct a new ship in particular, which costs multi-millions of dollars, that they agree to integrate into that equipment a standardized observing platform, which is, compared to the total ship cost, almost nothing, and which contributes to the safety and also to the efficiency of the ship. So that is something where we must be more convincing, and in that case, well, if you would have a standard equipment, then the whole company maybe would be able to standardize that in the whole fleet.
Great, and that points to another kind of, I mean, one sort of possible future avenue for SOT, which is to work more closely with industry in terms of having systems set up or standardized and included in ships, which would be an amazing contribution to the observing system. So I have a couple of questions which maybe are kind of forward-looking, and one of them I wanted to ask Darin, actually, having spent a year being SOT chair. What are the things that have most surprised you about this year, and sort of what are you looking forward to in the next couple of years?
Yeah, I think that being the SOT chair now for almost a year, I guess, or basically years we sit and talk right now. I think that the complexities of international cooperation engagement are there, and that's a very real thing. But I also think working internationally, we can, although you have to be patient and work through the I call it the bureaucracy, if you will, of not just my own organization, but organizations like the WMO and the IOC and others, to make sure that everything that you're trying to accomplish works through their framework, works through their technical requirements and so on. But you can really make some really lasting global change. And when you work through processes like that, I think that the changes that you make, if you have the patience to get through them and the patience to get through the coordination, the changes can really be enduring. So for example, Martin's talked about, through Emma, the last question mentioned, the coordination with industry, and the desire to get more observations in a number of different ways through changes in policies, such as possibly making things mandatory, or working with industry to get things put on ships as they're built, as opposed to installed later on. Those types of things, if we can achieve those in let's say in the next 10 years, which it may take that length of time to get things like that accomplished, could have lasting effects on the world for the centuries or more. The VOS program started back in the late 1800s. It probably started as a group of people who got together and thought ship observations would be good to have. And think about the length of time that probably took to coordinate internationally, particularly in a time where communication isn't as fast as today. But it's an enduring legacy. It's something that we have. I think that of course, like I say, that we come back full circle to the question. There's a lot of complexity in international engagement, but there's a lot of potential, I think, for making global change. It can be enduring for a long time.
Great. Well, that's a really nice vision, but also I would be inclined to agree that these things would take time, but to look 10 years out is also what we need to be doing, to have bigger ideas about how we can enact that change. This is a question, maybe, this webinar is a great opportunity to inform people more about the ship observations team and the work. Do you think I sometimes feel that the ship observations team doesn't have as much visibility as some of the other networks. Do you think this is something that we should be working on to help recruit ships and spread the word of the importance of the observations?
Yeah, this is Darin. Yeah, I think I really believe yes, and I find this sometimes when you work at National Weather Service, where the weather effects for people, a lot of people over land, really takes precedent, particularly from maybe a marketing and awareness standpoint. So tornadoes, hurricanes that affect people over land, flash floods, major winter storms. That tends to get the press, that tends to get the attention. However, all of the stuff out in the ocean, it still affects a lot of people, but a lot of times you don't hear about it until something really bad, unfortunate happens. There are more hurricane force wind events that we as an Ocean Prediction Center forecast in the North Atlantic and the North Pacific combined than any tropical hurricane systems that occur both in Pacific and the Atlantic in a season. It's probably we barely get through the alphabet sometimes, both oceans combined tropically, but in extratropical sense with low pressure systems there could be over 100 per year. Yeah, we need to continue to spread the importance, and all of you who are on the webinar today, can really help us with that. Engage with people and let them know that being weather ready, understanding our atmosphere, understanding our climate is really important, not just over land, but there's a whole bunch of earth out there. I think 70% or whatever it is covered by water. So having those observations from the top of the atmosphere to below the ocean surface is really important. And I think it kind of highlights again the importance of what the SOT tries to do.
Great. Okay. Well, we're pretty much at the end of our time, and I have to say thank you very much to all the audience for coming in and participating on the webinar, and all the really interesting and really great questions. Tomorrow, as I said, both the recording and the PowerPoint will be available online, because I know, Darin, that there were a number of links within the PowerPoint, and I think people wanted to follow up on those links and view the YouTube videos, which is great. As has also been mentioned, our next webinar will be in February, and it will touch into again the work of the SOT, but this time from the SOOP side of things, which is looking at XBT and long-term monitoring, more for climate applications, but also others. And I would also pass my great thanks on to Darin and to Martin for doing such a great job and taking us through the work of the SOT. So thank you very much, guys. And that's really it. So I guess it just remains to say I hope that everybody has some happy holidays in the next few weeks, and we look forward to getting back together in the new year for some more in the Goose series of webinars. Great, thank you. Thanks, guys, and thank you, audience. Bye.